Today we'll start with the next topic, that is VLSI and ASICs. So as the name itself will indicate, VLSI is what? Very large scale integration, and ASICs is application specific instruction set computers. Right? So 1980s, so very large scale integration came into existence during the year 1980s. So then ULSI, ultra large scale integration. Then further what? ಮುಂದೆ ಇನ್ನು ಎಷ್ಟು number of transistors you want to keep ICs. So VLSI now just means the IC design. That means what? In the present case now, very large scale integration is nothing but integrated circuits design. So application specific instruction computers ಅಥವಾ even ICs also you can call integrated circuits. So enabled by the CAD tools. ಅಂತಂದ್ರೆ we are using now for digital design only CAD tools, right? So CAD tools, foundry services. So what will happen before you design the chip? So you write the design specifications, you write the coding, then you convert it, then you see the simulation, then you try to implementation, and finally the chip is fabricated. Often designed for range of related products in the market segment. So application specific standard products, we call them as ASSP. You can write this long forms ಬರ್ಕೊಳ್ರಿ. ASICs into ASSP. So the best example always he is given is cell phone. Cell phone again integrated circuit ಇರ್ತದಲ್ಲ, ಅದು cell phone ICs, right? So ASIC has lower unit cost than the FPGA. See here, this is very important. What I have told you, there is an development board. Development board nothing but your PC, right? And there is a target board, right? So target board. So here what you are doing, you are writing in Verilog code, you are saving it, right? Then what you are doing, you are removing all the logical errors. Then you are trying to simulate. You are using the simulation, using the simulator, you are trying to simulate your code. So you are giving the test vectors, inputs, outputs and all. So finally you are verifying whether it is working correctly or not. Once it is verified, then what you have to do? You have to go for implementation. So for implementation, now the target device may be what? I have told you, either it could be a CPLD, that is complex programmable logic device, or FPGA, that is field programmable gate device, FPGA. So these CPLD and FPGA are nothing but an array of, inside they will have array of and or logic, right? So they are the empty ICs will be there on chip here, empty ICs with n number of switches for inputs, LEDs and IO pins. So here you might connect your either stepper motor or 7-segment display, anything, right? So whatever code you have written here. Now apart from this CPLD or FPGA, one more thing is ASIC. ASIC is what? Application specific integrated circuit, also you can call application specific integrated chip if you call here. That means the best example what I can say here is like this, your ovens, your washing machine, right? Anything, your mobile phones. Once the program is being written, you are not going to change the program, right? That means what? Fixed code, fixed program for dedicated application, right? Those are ASICs, application specific instruction computers are ASICs. Whereas CPLD and FPGA are going to act as general purpose. Means what? Through a cable, right? So it could be a serial port or JTAG cable. What you are doing, whatever hex codes generated here, 0, 1, anything, entire for code, that hex code is dumped into this, right? So that time the CPLD, or the difference is what? Both are having and or array only. The capacity is less here, whereas in FPGA the capacity is more. That's all. Depending on the application, you can choose either whatever you want. If you want CPLD, you can choose CPLD, or if you want FPGA, you can choose FPGA. So they are the general purpose thing. Once if I have written a code for what? Full adder, half adder. So full adder I will write, I will dump, then this will be acting as full adder. Now next time what I will do, I will write a program for stepper motor control. Again I will dump. So first program is erased, second program is written here. That time this chip is acting as what? And this for stepper motor control, right? So they will be acting as general purpose systems. Whereas in ASICs, what will be having is, once you have written a code in an ASIC, application specific, think now for washing machine only 1 kilobyte of ROM is needed. So if I use that, I write a program, then lifelong that program will not be changed, right? So that's why it is what? Fixed code is written for a dedicated application in ASIC, right? So as the name itself will indicate, it is application specific. Whereas these CPLDs, FPGAs, and all those things, PLAs, programmable logic arrays, all these are general purpose. So you can like our this only, our CPU, general purpose laptops and computers, what they are using, like that only. This target board is also general purpose. So once you can store whatever codes you want, and you can use it, right? So ASIC has a lower unit cost. See, ASIC has a lower unit cost than field programmable gate array, but more design verification efforts are needed. Higher non-recurring engineering cost, right? Amortized over the product run. That means higher non-recurring. See, NRE ಅಂತಂದ್ರೆ ಏನು? See, NRE. See, simply cost of a product. Think now, washing machine, if I am paying 70K for one washing machine, but initial design of washing machine is required. No, you need hardware support, hardware engineers, you need software engineers, what all to be implemented, all that. First design, for the first design of one washing machine, or I have taken an example of one washing machine. So first design of one washing machine, whatever is needed, that is called as non-recurring engineering cost. Later, how they fix the price? Think now. ಆ ಸೈಡಿಂದ ಹೋಗ್ರಿ. ಯಾವುದು? ಚಿನ್ನು ಕಾಲ್ ಮಾಡ್ರಿ. ಇಲ್ಲದ್ರೆ ಇಲ್ಲೇ ಒಳಗಿಂದ ಬಂದ್ಬಿಡ್ರಿ. Okay, now if I have designed 10 washing machines, then what I will do? Think the actual washing machine cost might be for designing 10 60K, but original first designing whatever cost will be there, no, that NRE cost, if this has taken 60K, what they will do? They will divide it by all this and they will put upon all the others. So that's why the total cost of each washing machine will be 70K. That means what? Initial designing whatever amount will be there, that will be amortized. Amortized ಅಂತಂದ್ರೆ divided by, and that will be put upon the other units. So that's why see, higher non-recurring engineering cost. Higher ಅಂತಂದ್ರೆ initial first product, ಒಂದು product ಮಾಡಕ್ಕೆ ಜಗ್ಗಿ ರೊಕ್ಕ ಬೇಕಾಗ್ತದೆ. So higher non-recurring engineering cost, which is amortized over the production run. Further ಹೆಂಗ್ production start ಆಗ್ತದಲ್ಲ, then what will happen? On that the money will be put, right? So like that it is. ASICs makes sense for high volumes. So ASICs makes sense for high volumes. High volume ಇದ್ರೆ ಅಷ್ಟೇ. ಇಷ್ಟೆಲ್ಲ ಕಷ್ಟಪಟ್ಟು ಒಂದು ವಾಷಿಂಗ್ ಮಷಿನ್ ಡಿಸೈನ್ ಮಾಡಿರ್ತೀರಿ, ಒಂದು 10-20 ಮಾರ್ಕೆಟ್ನಾಗ ಸೇಲ್ ಆದ್ರೆ you will not get any advantage. So ASICs make sense for high volumes, right? Full custom design each transistor and wire, high NRE cost but best performance and least area. Because ಆ ಪರ್ಟಿಕ್ಯುಲರ್ ಅಪ್ಲಿಕೇಶನ್ ಎಷ್ಟು ಮೆಮರಿ ಬೇಕು ಅಷ್ಟೇ ಹಾಕಿರ್ತೀರಿ, ಎಷ್ಟು IO ಲೈನ್ಸ್ ಬೇಕು ಅಷ್ಟೇ ಹಾಕಿರ್ತೀರಿ. So that's why high NRE but best performance and least area. Standard cell, that is use basic components from a foundry library. That means whatever the inbuilt these are there, components are there, them only, those only you are going to use, right? Next, in this first device, that is programmable logic devices. PLDs can be programmed after the manufacturer to verify their function, right? So fixed function, that is SSI, MSI, ICs, for that you are going to use higher unit cost than ASICs but lower NRE cost. Initial manufacturing ಗೆ ಭಾರಿ ಕಮ್ಮಿ ಬೇಕಾಗ್ತದೆ ಇದಕ್ಕೆ. And ideal for low to medium product volumes. So low to medium product volumes, we will use this PLDs, right? One second. See here. So programmable logic devices. So first one, program in PLDs, first one is PALs, that is programmable array logics, introduced by monolithic memories in 1970s. First widely used, they are the first kind of PLDs. So first kind of PLDs is programmable array logics, PALs, programmed by blowing the fusible links in the circuit. So whichever you don't want, those links will be blown off. Think if I want to store 1010, then this cell I will blow off the fuse. Permanently the connection will be lost. So programmed by blowing off the fusible links in the circuit. Use a special programming instrument. So for doing this, a special programming instrument is being used. So the example is PAL 16L18. Compulsory this will come, PAL 16L18. So 16 inputs. Chinna, 16 inputs, 8 active low outputs. So PAL 16L18, where 16 indicates 16 inputs are there, 8 indicates active low outputs. So PAL 16R8, so 16 inputs, 8 registered outputs. So here R indicates registered outputs. So you might have seen in the initial classes there we had studied what is the advantage of registered inputs and registered outputs we had seen, right? So here the outputs are registered. So PAL 16L8 and PAL 16R8. So example of schematic PALs, you can just see there. If you, I told you, it is an and it will internally have an and or array. I had told you. That means what? If you think this as an one IC, PALIC, right? PALIC, inside what will be there? It will be having an and or array will be there inside. So let us see how does this works. So you can see there example schematic of a PAL. I have 3 inputs, X1, X2 and X3. And now X1 is again inverted. So here what I will get, X1 bar. On this X1 bar, this is X2 bar line. All of you are getting this?
Yes, ma'am.
All of you are with me?
Yes, ma'am.
Okay, X3 bar. So this is plain, then this is inverted input. Plain input, no inverted, non-inverted, inverted input are there. Then you see I have a function here. What is the function? X1, X2, X3. I have the function. This I need to implement. This is the digital logic I need to implement now. So X1, X2, X3 dash. X3 dash is there. So what I am doing, this is the x1 line, right? So x1, then next x2, so this fellow x2, then next you see x3 dash. This is x3, whereas this is x3 dash line. There is no connection on the other lines. So all these three are ANDed. So I am having an AND gate here. So all these three are ANDed. So I got the product P1. So I have mentioned this as P1. So product P1. Then next, what is the next product? X1 dash, X2 and X3. So this is X1 line. This is X1 dash. Then next X2. So directly this is X2. Then next what? X3. X3. All these three are ANDed. All these three are ANDed, and I get the product P2. So this is the product P2. So again what I am doing, I have to OR P1 and P2. So P1 is ORed with P2. So what function I will get to get the function F1. Is it clear to you all? How inside the PAL will be there? So whenever you write any function after simulation, it's a digital code. If you send into a target PAL board, then internally the design will be fused like this. Is it clear to you all?
Yes, ma'am.
Yes. So now look at the second function. Second function is what? X1 dash X2. So where you should get, this is X1 line. This is X1 dash. So this I need to mark. So there is interconnection between this line. So X1 dash and X2 dash. So this is X2 line. This is X2 dash. That's all. So X1 dash, X2 dash. So through an, I will pass through an AND gate. So I am going to get the product P3. So this I have mentioned as product P3, X1 dash, X2 dash, ORed with next what is asked, X1, X2 and X3. So X1, X2 and X3. So this is passed through one more AND gate. So I am going to get the product P4, right? So this is P4. So later what I need to do, P3 ORed with P4. So P3 is ORed with P4 to get the function F2. So like this, the functions F1 and F2 are implemented using an and OR gate, right? So this is called as, so you can see there. So this is what, so entire this is called as and plane. Full this structure, whatever is there, this is called as and plane. And all these are OR structures here. So now whenever it is being asked, so PAL, programmable array logic, so it is part of the PLD. PLD is what? Programmable logic devices. In programmable logic devices, the first type what we are studying is PAL, programmable array logics, right? So it is nothing but inside this IC what will be there? Just an array of and OR gates will be there. Depending on the function internally, it will be mapped, it will be routed. Is it clear to you all? Is the example schematic of PAL is clear to you all?
Yes, ma'am.
Okay. So after going home, you can draw this. Next, we need to study the example of PAL. What is PAL 16L8? No? So compulsory. Now you see there. Internal circuit of PAL 16L8. So PAL 16L8. 16 indicates what?
Input.
16 indicates what?
Inputs, ma'am.
16 indicate inputs. Then 8 indicates
Outputs, active low outputs.
8 indicates active low outputs. So you can see there. One nimsha. Inputs you can see. example is being given I1, I2, I3. I1 and I2 is one thing and get ORed with I3 and I10. I1, one second. ಇದು ಹೆಂಗೆ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ಬೇಕೀಗ? Output 1, output 1, output 2, I1, I2. I'm unable to see this. Zero, 1, 2, 3, 1. ಟೋಟಲ್ ಎಷ್ಟು ಬರ್ಬೇಕಿಲ್ಲಿ? ಬಫರ್
Ma'am, horizontal 10 line.
ಒಂದು ನಿಮಿಷ. ಸಂಧ್ಯಾ, ಯು ಜಸ್ಟ್ ಚೆಕ್. ಯಾರಾದ್ರೂ ಹೆಲ್ಪ್ ಮಾಡಿ, ಒಂದು ನಿಮಿಷ ತಡ್ರಿ. ಹಾರಿಜಾಂಟಲ್ 10 ಲೈನ್ಸ್ ಅಲ್ಲ, IO 01. You just check this cross.
Horizontal, ma'am. Vertical.
One ನಿಮಿಷ. I0 ಇಲ್ಲಿಂದಲ್ಲ ಅದು. ಒಂದು ನಿಮಿಷ ತಡ್ರಿ. ಕ್ವೆಶ್ಚನ್. For each output we can form an and or inverter. In the circuit showing in figure 1, output 1 O1 implements the function. Okay. So you can just check the crosses here. Output 1, one ನಿಮಿಷ. Output 1. Okay. In the circuit shown in figure, output O1 implements the function I1 into I2, I3 and I10 bar. You check this I1, I2, I1, I2, I3 and I10 bar and its complement. Because inverted outputs, no? I1, I2, first ones, I1, I2, then what else is there? I10 bar. I8 and I10 bar. I10 is here. ಎಲ್ಲೋ ಮಿಸ್ ಆಯ್ತಲ್ಲ ಇದು. ಕ್ರಾಸ್ ಲೈನ್ಸ್ ಚೆಕ್ ಮಾಡ್ರಿ ಒಂದ್ ಸ್ವಲ್ಪ.
Ma'am, horizontal 8 lines, ma'am. Sorry. Horizontal 8 lines, ma'am. Vertical 10 lines.
Vertical 10 lines ಎಲ್ಲಿ ಬಂತು?
10 lines, ma'am.
16 inputs and 8 outputs are there. So see here, output 1, right?
0 to 9, 22.
No, output 1, see there, not like that. Output 1, this is I1. Input 1. Input 1 and input 2. One line is directly connected. Another line is inverted. Right? Directly and invert I1. This is I1 line. I1 line, I1, and you should get I2 line. I1 into I2, then I3. IO3, I3 where it is, you see there, I3 here, I3, then I10 bar, I10, 10 where it is, 1 nimsha, I10, I10, I3, I10, 1 nimsha. For each output, we can form an AND or invert function of inputs. In the circuit shown in figure, input 01 implements the function I1, I2, I3, I10 bar and the whole bar complement with the output enabled by the condition I8 and I10 bar. I8 and I10 bar. Even parallelly vertical I8 to I10 nu nodbeku. Down nodri I8 and I10. This is output 8. I10. I10 is here, I10 bar is here. So I10 bar. One more was what? One more was what? I8. Why he has shown the cut here? I8. Sixteen inputs and 8 outputs. Okay. Output 1 is there. Input 1. Input 2. I1. Directly I1. Okay. Output 1. Output 1. Input 1. Input 2. See, some are multiplexed. IO2. Input output 2. Both input and output 2 is there. I3. So like that only. IO7 is there. Input output 7. Like that only. 18. Input 8. Input 8. Output 8. Then finally input 9. Then input 10. Alright. So it is going to continue like this only. Some of the pins are bidirectional, both it is acting as input as well as output. See there, this is acting input as well as output also. Output also it is acting. So now what function we need to implement? For each output, we can form an AND and OR invert function of the inputs. In the circuit shown in figure, output 01 implements the function I1, I2 ORed with I3, I10 bar and the whole bar. So O1, we should check for O1 with the output enabled by the condition I8 and I10 bar. Check for O1, check for output 1. We need to check for output 1, O1. O1 has to be implemented what? I1 into I2. So these are the I1, I2 lines. So I1 pin, this indicates up to here. So I1, first one, I1 and I1 ANDed with I2. First AND gate, this you see, idu first AND gate idu. Then second AND gate idu. Then these two, but from where they are coming, that we should see. I1, 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 I2. Second one, I3, I10 bar. I3, I3, directly I3. And I10 bar. I10 is this line. I10 bar is this line. I3, I10 bar. Then I8 and again I8 and I10 bar. I3, I8 and I8. I8, I8 and I10 bar. This line I8 and I10 bar. Okay. All of you are with me?
Yes, ma'am.
Akash, Sandhya, see
Yes,
here.
ma'am.
So what AND and OR gate array we had seen, now in the PAL 16L8, so we need to have 16 inputs and 8 outputs, right? So here in the figure, what is being done is ella pins nodralle, anything you see, some of the pins are single, like only they are acting as input lines, but some pins are acting as output lines. I'll take some other color. So if you see, this is what input 1. That means what inputs you see there, directly inputs are acting as what I1. This is the pin connection here. I1 and this is I2. So we are using a tri-state buffer here. There is non-inverted line is also there, and with a bubble inverted line is also there. So in the previous case, what we had done, X line we had taken, we had used an inverter and we had taken one more line, right? So like that only X2 we had taken and one more inverter. Rather than doing like this, what is being done is any one pin is being taken like this, and two lines are generated. One is non-inverted and one more is inverted line. Right now, if the cross lines are there, whichever connection you want, you need to cross it. That's all, just to show that. So you can see here. So what is being done is, so output is also designed, inputs are also there. So you can see the inputs first, I1, right? This is I2. So one is pure line and another one is inverted line. Similarly for I1 also, one pure line and this one is inverted line. So what you need, I1 you need and I2 also you need. So that's why I1 and I2, this first one. Are you getting this, all of you? I1, I2 are taken here for the first AND gate. Output is done on the O1. So you need I1 line and I2 line cross done, right? Which is on the first AND gate. All of you are with me?
Yes,
Yes,
ma'am.
ma'am.
Similarly, other pins are generated. I3, right? Output 1. This is what? IO2, right? Output 2. Similarly, like this only, he has shown the dotted lines here. I8, like that only it will be there. For us, whichever is needed, that we have taken. I1, I2. Then next, what you need? I3 and I10. So come to I3 line. So I3 is here, right? I3 line. This is projected here, I3. For the next AND gate, I3 and I10 bar. Come to I10. I10, I need the bar line. This is the pure line. Both I9 and I10 is also there. I10 bar. This line, I10 bar line. So for this AND gate, what is there? For this AND gate, I3 and I10 bar is there. Alright? And both has to be ORed. That means this is sent through an OR gate, right? The output is what? Inverted output, I10 and the whole bar. That's why through the inverter, right? And now output is also controlled by what else? I8 and I10. I8 line, check this. From where it is coming? I8 line. I8 and again the same thing, I10 bar. The same line is projected here. I10 bar. This is the output, right? So I1 into I2, I3 and I10 bar. So like this, in internally total he has to show the 16, but what is being done, all the internal simply it is shown as dots. So only one or two structures if you see, compulsorily this question you are going to 10 to 12 marks question you are going to get, right? So compulsorily you will have to show this structure there. So what we are doing as an example, for each output, we can form an and or invert functions of the inputs. Each output in the circuit shown in figure, output O1, that is the output 01. The output O1, what we are doing, the output 01, the output O1 implements the function I1 into I2 and I3 into I10 bar with the output enabled by the condition. So output is enabled by this condition. So output kuda enabling one condition kottide illi. So that output enabling condition is this. What is that? I8 and ANDed with I10 bar should be there to enable the output, because output is also in tri-state inverter there. ಬರೀ ಜಸ್ಟ್ ಔಟ್ಪುಟ್ ಇಷ್ಟೇ ಇತ್ತಂತಂದ್ರೆ ನೀವೇನ್ ಫಂಕ್ಷನ್ ಹಾಕಿದ್ರಿ ಈಗ? ಸಿ ದೇರ್, ಸಿ ಇಫ್ ಒಂದ್ಸರ್ತಿ ಎಲ್ಲ ವ್ಯಾಲ್ಯೂಸ್ ಹೇಳ್ರಿ ನನಗೆ. ಆಲ್ ಆಫ್ ಯು ಟೆಲ್ ಮಿ ದ ವ್ಯಾಲ್ಯೂ. ಸಂಧ್ಯಾ ವ್ಯಾಲ್ಯೂಸ್ ಡೈರೆಕ್ಟ್ ಮಾಡು. ಫಂಕ್ಷನ್ ಹೇಳಿ ನನಗೆ. ಫಂಕ್ಷನ್ ಯಾವ್ದ್ಯಾವ್ದು? I1 ನೆಕ್ಸ್ಟ್ ಸೆಕೆಂಡ್ ಒನ್
I,
ANDed with ANDed with I2. Then next one AND gate ಆಯ್ತು. ಇನ್ನೊಂದೇನು I3. I'm just taking the I3 line. I3 and ಇನ್ನೊಂದೇನು I10 bar. So something if I take next line as I10, inverted I10 bar if I take, so both through an AND gate and OR gate, and finally if I have the output function what we had done in PAL, now he is telling that it is an inverted output. So if I pass through an inverter, iste alla idu. Again what he is telling is, this is again tri-state by one more input. What is that? One more, it has to be enabled by one more AND gate. What is that he is telling? I8, you should get I8, and what is the one more thing? I10 bar. I10 bar. That means it is not only the inverted output, but also it is tri-state. It has to be enabled by this condition. All of you are getting this? Sandhya, Akash, Manu, Hafsa, Free. ಇಲ್ಲ ಏನ್ ಹೇಳಕ್ ಟ್ರೈ ಮಾಡಕತ್ತೀನಿ ಅಂತಂದ್ರೆ PIL ನಾಗೆ ನೋಡ್ರಿ, ಇಲ್ಲಿ ಕ್ಲಿಯರ್ ಮಾಡೋದ್ ಬೇಡ. PIL ನಾಗ ಏನಿತ್ತು? AND and OR ಫಂಕ್ಷನ್ ಗೆ ಇಲ್ಲಿ ನೋಡ್ರಿ, F ಫಂಕ್ಷನ್ ಏನಿತ್ತು? x1 x2 x3 ಬಾರ್ ಪ್ಲಸ್ x1 ಬಾರ್ ಏನೋ ಇದನ್ನ ಮಾಡಿದ್ರಿ ನೀವು, ಮಾಡಿ OR ಗೇಟ್ ನಾಗ ಹಾಕಿ ಫೈನಲ್ ಏನ್ ಬಂದದಕ್ಕೆ ಅದಕ್ಕೆ F1 ಅಂತ ಬರೆಯಕತ್ತಿದ್ರಿ, F2 ಅಂತ ಬರೆಯಕತ್ತಿದ್ರಿ. ಈಗ ಇಲ್ಲಿ ಈ 16L8 ನಾಗ ಏನೈತಂತಂದ್ರೆ ಔಟ್ಪುಟ್ ಫಂಕ್ಷನ್ ಈಸ್ ಅನ್ ಇನ್ವರ್ಟೆಡ್ ಫಂಕ್ಷನ್ ಅಂದ ತಕ್ಷಣ ಏನಾಗ್ಬಿಡ್ತು? ಕ್ಲಿಯರ್ ಮಾಡ್ತೀನಿ ತಡ್ರಿ. ಔಟ್ಪುಟ್ ಫಂಕ್ಷನ್ ಈಗ ಇಲ್ಲಿ ಎರಡು ಕಂಡೀಷನ್ ಹೇಳಕತ್ತಾನೆ. ಇದು ಬರೀ ನಾವು ಜನರಲ್ ನೋಡಿದ್ವಿ, AND and OR array. ಇದಂತೂ ನಿಮಗೆಲ್ಲ ತಿಳಿದತ್ತಲ್ಲಪ್ಪ, ಹೌದಾ ಇಲ್ಲ? ಇಂಟರ್ನಲ್ಲಿ ಇದೆ AND and OR array ಐತಿ. ಈಗ ಆ ಎಕ್ಸಾಂಪಲ್ ನಾಗೆ 16L8 ಎಕ್ಸಾಂಪಲ್ ನಾಗ ಏನ್ ಹೇಳಕತ್ತಾನಂದ್ರೆ ದ ಔಟ್ಪುಟ್ಸ್ ಆರ್ ಇನ್ವರ್ಟೆಡ್ ಔಟ್ಪುಟ್ಸ್. ಸೊ ಇನ್ವರ್ಟೆಡ್ ಔಟ್ಪುಟ್ಸ್ ಅಂದ ತಕ್ಷಣ ಕಂಪಲ್ಸರಿ ಒಂದು ಇನ್ವರ್ಟರ್ ಬರ್ಬೇಕಿಲ್ಲ ಔಟ್ಪುಟ್ಸ್, ಹೌದಾ? ದ ಔಟ್ಪುಟ್ಸ್ ಆರ್ ಇನ್ವರ್ಟೆಡ್ ಔಟ್ಪುಟ್ಸ್. ಅವಾಗ ಏನಾಗ್ತತಿ, ಇದು ಏನ್ ಫಂಕ್ಷನ್ ಇರ್ತತಿ, ಇದ್ರ ಮ್ಯಾಲ ಒಂದು ಬಾರ್ ಇರ್ತತಿ, ಹೌದಾ? ಇನ್ವರ್ಟೆಡ್ ಔಟ್ಪುಟ್ಸ್. ಮತ್ತದಲ್ಲದೆ ಏನ್ ಹೇಳ್ತಾನಂತಂದ್ರೆ ದೇ ಆರ್ ಆಲ್ಸೋ ಗವರ್ನ್ಡ್ ಬೈ ದ ಔಟ್ಪುಟ್ ಫಂಕ್ಷನ್. ದಟ್ ಮೀನ್ಸ್ ಟ್ರೈ-ಸ್ಟೇಟ್ ಬಫರ್. ಅವು ದೇ ಆರ್ ಗವರ್ನ್ಡ್ ಬೈ ದ ಔಟ್ಪುಟ್ ಫಂಕ್ಷನ್. ಇದಕ್ಕೆ ಔಟ್ಪುಟ್ ಫಂಕ್ಷನ್ ಇಲ್ಲಿ ಏನ್ ಕೊಟ್ರೆ, ನಾನು ಇದಕ್ಕೆ ಔಟ್ಪುಟ್ ಫಂಕ್ಷನ್ ಏನ್ ಕೊಡ್ಬೋದಾಗಿತ್ತು? ಸಮಥಿಂಗ್ ಇಫ್ ಐ ಸೇ x2 and x3 ಅಂತಂದಿದ್ರೆ ಏನಾಗ್ತಿತ್ತು? ನಾನು ಏನ್ ಮಾಡ್ಬೇಕಾಗಿತ್ತು ಅವಾಗ? x2 ಮತ್ತೆ x3 ಲೈನ್ ತಗೊಂಡು ಅದನ್ನ ಒಂದು AND ಗೇಟ್ನಾಗ ಹಾಕಿ ಅದನ್ನ ಇಲ್ಲಿ ಮಾಡಿದ್ರೆ, ಸೊ ಕಂಪಲ್ಸರಿ x2 x3 ಇದು ಬಂದಾಗ ಇದು ಔಟ್ಪುಟ್ ಕಂಪ್ಯೂಟ್ ಮಾಡಿದಾಗ ಇನ್ವರ್ಟ್ ಮಾಡಿ ಕಳಿಸ್ತೈತೆ, ಅವಾಗ ಫಂಕ್ಷನ್ F ಬರ್ತೈತೆ. ದಿಸ್ ಇಸ್ ವಾಟ್ ಈಸ್ ದ ಚೇಂಜ್. ಸೊ ಹಿಯರ್ ಡೈರೆಕ್ಟ್ಲಿ F we are getting here, but in 16L8 it is an inverted output, again controlled by this output line. ಇದು ಇದ್ರೂ ಇರಬಹುದು, ಇಲ್ದಿದ್ರೂ ಇರಬಹುದು. So in the present example, one example what he has shown for O1, he is telling that's why you see there the inputs are shown with the green lines, then the output enabling is shown by an yellow line. Is it clear to you all? ಗೊತ್ತಾಯ್ತಾ ಇದು?
Yes.
This is very important. Right? Earlier we were getting our F here only. Now we are getting F bar inverted output plus controlled by this fellow. Right? Tri-state buffer. Ella time in controlled irbekantene illa, but still the outputs are designed like this. If you want, you can have the controlled outputs also. So the thing is I1, so you can check the I1 line here. So I1, first one, so see there, I1, I2 going in one AND gate, this fellow. Second one, I3, I10 bar, come to I3. Directly I will take this I3, come to I10. I10 also, one is inverted and one is non-inverted. So I will take I10 inverted. Here cross line is there. So that's why I3 and I10 in one more AND gate. So this is going to form the outputs, these two are ORed, and I'm going to get the inverted function. But still he is telling that it has to be enabled by this output function. So that output function is I8, come to I8. I8 line, then I10 bar. So I10 bar, the same I10 bar is projected here, taken here. So these two are sent through this AND gate, then that is connected to this fellow. Is it clear to you all of you? Yes?
Yes, ma'am.
Other dots are shown, but that you need not worry. For our function, only this is being taken. But here the dotted lines is shown. That means all the internal IOs are not being shown here. Right? So only output 1, input 1, input 2. Like this you can draw the inputs. Input 3, right? So randomly it is being shown. For the function to explain what all we need, only those many inputs are shown here. So only this much also you can show and complete. Is it clear to you all of you?
Yes, ma'am.
So for each output, we can form an and or invert function of inputs. Invert function nodri, output is inverted, and or invert function of the inputs. In the circuit shown figure, output O1 implements the function I1, I2. ಹಂಗೆ ಎಕ್ಸಾಂಪಲ್ ತಗೊಂಡಾನ, ನೀವು ಯಾವ್ದಾರ ಮತ್ತೆ ಯಾವ್ದಾರ ತಗೊಳ್ರಿ, ನೀವು ಯಾವ್ದಾರ ತಗೋಬಹುದು. ನೀವೆಲ್ಲ ಡ್ರಾ ಮಾಡಿದ್ರೆ I1 ಬಾರ್ ಅಥವಾ I4 ಆರ್ಡ್ ವಿತ್ ಓನ್ಲಿ I3 ಬಾರ್, ಈ ಟೈಪ್ ಏನ್ರೆ ಎಕ್ಸಾಮ್ನಾಗ ನೀವು ಯಾವ್ದಾರ ತಗೋಬಹುದು. ಜಸ್ಟ್ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಹಿ ಹ್ಯಾಸ್ ಶೋನ್. ಇಲ್ಲಿ IO1 ಗೆ ಇಂಪ್ಲಿಮೆಂಟೇಷನ್ ತೋರಿಸಿ, ನೀವು ಔಟ್ಪುಟ್ 2 ಗೆ ಇಂಪ್ಲಿಮೆಂಟೇಷನ್ ಕೂಡ ತೋರಿಸಬಹುದು ನೀವು, ರೈಟ್? ಇನ್ ದ ಎಕ್ಸಾಮ್ಸ್ ಇದನ್ನೇ ಫಂಕ್ಷನ್ ತೋರಿಸ್ಬೇಕಂತಿಲ್ಲ, ಇದನ್ನೇನು ಬೈ ಹಾರ್ಟ್ ಮಾಡೋದು ನೆಸೆಸರಿ ಇಲ್ಲ. Just for our explanation, this is being shown. You can take any randomly, any function there, right? So in the circuit shown figure 1, O1 implements the function I1, I2 and I3, I10 bar with the output enabled by the condition. Output enabled by the condition. That's why output, you have an inverted output which is enabled by the condition. This is the condition line. What it is enabled by the condition? I8 ended with I10 bar. ಇದು ಕಂಡೀಷನ್ ಇರ್ಬೇಕಂತೇನಿಲ್ಲ, ಬಟ್ ದಿಸ್ ಈಸ್ ಎನೇಬಲ್ಡ್ ಬೈ ದ ಕಂಡೀಷನ್ ಅಂತ ಹೇಳಿದಾಗ ಇದನ್ನ ಔಟ್ಪುಟ್ ಕೂಡ ಮಾಡ್ಕೋಬೇಕು ನೀವು ಅಲಾಂಗ್ ವಿತ್ ದ ಇನ್ಪುಟ್ಸ್. ಇದು ಎಲ್ಲಿಂದ ಬರಕತೈತಿ? ಇದು ಆರ್ ಗೇಟ್ ಇಂದ ಬರಕತೈತಿ. ಆರ್ ಗೇಟ್ ಇಂದ ಮತ್ತೆ ಎಲ್ಲಿಂದ ಬರಕತ್ತಾವ ಇವೆಲ್ಲ ಇನ್ಪುಟ್ಸ್? ಆ್ಯಂಡ್ ಗೇಟ್ ಇಂದ ಬರಕತ್ತಾವ ಇಲ್ಲಿ. ಸೊ ಇಲ್ಲಿ ಫಸ್ಟ್ ಆ್ಯಂಡ್ ಗೇಟ್ ಏನೈತಿ? I1 ಇಂಟು I2 ಐತಿ. ಸೆಕೆಂಡ್ ಆ್ಯಂಡ್ ಗೇಟ್ನಾಗ ಏನೈತಿ? I3 ಡಾಟೆಡ್ ವಿತ್ I10 ಬಾರ್ ಐತಿ. ಸೊ ಬಾರ್ ಐತಿ, ಅದು ಥ್ರೂ ಏನ್ ಆರ್ ಗೇಟ್ ಬಂದ್ಬಿಟ್ಟು ಇಲ್ಲಿ ಇನ್ವರ್ಟರ್ಗೆ, ಇದು ಇಲ್ಲಿ ಮತ್ತೆ I8 ಅಂಡ್ I10 ಗೇಟ್ ಇಂದ ಬರಬೇಕು. ಸೊ ಇಲ್ಲಿ ಈ ಆ್ಯಂಡ್ ಗೇಟಿಗೆ I8 ended with I10 bar. Is it clear to you all?
Yes, ma'am.
All
Yes, ma'am.
all of you unmute and tell me, is it clear how it is implemented?
Yes, ma'am.
Yes, ma'am.
Just it is an array of and or gate internally. ಯಾವುದೇ ಫಂಕ್ಷನ್ ಕೊಡ್ರಿ ನೀವು, ಏನಂತಂದ್ರೆ ಇಲ್ಲಿ ಅಲ್ಲಿ PLನಾಗ ನಾನು ಅಲ್ಲಿ X1, X2, X3 ಸಿಂಪಲ್ ಬರೀ 3 ಇನ್ಪುಟ್ಸ್ ತಗೊಂಡಿದ್ದೆ. ಇಲ್ಲಿ 16 ಇನ್ಪುಟ್ಸ್ ಇರ್ತತಿ, 8 ಔಟ್ಪುಟ್ಸ್ ಇರ್ತಾವೆ ಇಲ್ಲಿ PAL. ಸೊ ಲಿಟಲ್ ಬಿಟ್ ಲಾರ್ಜರ್ ವರ್ಷನ್ ಅಷ್ಟೇ. And one more difference is what? The output is inverted and it is output enabled by the condition. It is a condition. So tri-state buffer type work ಆಗ್ತದೆ ಇದು. So here with the output enabled by the condition, I8 ended with I10 bar. Okay. Then next, 16L 16L8 ನೋಡಿದ್ವಿ. 8 R ಅಂತಂದ್ರೆ ರಿಜಿಸ್ಟರ್ಡ್ ನಾಗಿ ಏನ್ ಚೇಂಜ್ ಇರ್ತೈತೆ ಅಂದ್ರೆ ನೋಡ್ರಿ ಇಲ್ಲಿ. So what is being done? The registered output circuit of a PAL 16R8. So here you have an AND array. ಅದೆಲ್ಲ AND array ಮುಗಿಸಿ ಇಲ್ಲಿ ಆರಿಗೆ ಬಂದ್ಬಿಟ್ಟು ಡೈರೆಕ್ಟ್ಲಿ ಔಟ್ಪುಟ್ ಏನಾಗಬೇಕಾಗಿತ್ತು? ಔಟ್ಪುಟ್ ಶುಡ್ ಬಿ ಥ್ರೂ ಎನ್ ಇನ್ವರ್ಟರ್. ಮತ್ತೇನಾಗಬೇಕಾಗಿತ್ತು? ಡೈರೆಕ್ಟ್ಲಿ ಇಲ್ಲೇನಾಗಿತ್ತು? ಈ ಪಾರ್ಟ್ ಇದ್ದಿಲ್ಲ. This part was not there. There was no register there in the previous case. Directly the output was connected to an inverter, right? And a tri-state control signal was there. But now what is being done? It is connected through an resistor R. That is important. The output is registered. So the PAL components also include the registers, allowing us to implement a simple sequential circuits. So see there, through D, so output is connected to the D, the value is latched here, then Q is connected to the output pin, then Q bar that is implementing here for inputs here, right? So inverted, right? Output pins and input pins. So PAL components are also include registers, allowing us to implement the simple sequential circuits. So registers irodrinda even sequential circuits kuda ನೀವು ಡಿಸೈನ್ ಮಾಡಬಹುದು. ಸೊ ಫೀಡ್ಬ್ಯಾಕ್ ಪಾತ್ ಈಸ್ ಆಲ್ಸೋ ಯೂಸ್ಫುಲ್ ಫಾರ್ ಇಂಪ್ಲಿಮೆಂಟಿಂಗ್ ದ ಫೈನೈಟ್ ಸ್ಟೇಟ್ ಮಷಿನ್ಸ್. ಸೊ ಈ ಫೀಡ್ಬ್ಯಾಕ್ ಪಾತ್ ಇರೋದ್ರಿಂದ ಫೈನೈಟ್ ಸ್ಟೇಟ್ ಮಷಿನ್ಸ್ ಅನ್ನ ಇಂಪ್ಲಿಮೆಂಟ್ ಮಾಡಬಹುದು ನೀವು. ಸೊ ದಟ್ಸ್ ವೈ ಇಂಪಾರ್ಟೆನ್ಸ್ ಆಫ್ ಯೂಸಿಂಗ್ ದ ರಿಜಿಸ್ಟರ್ಸ್. ಸೊ ಅದರ್ವೈಸ್ ಡೈರೆಕ್ಟ್ಲಿ ಫ್ರಾಮ್ ಎನ್ ಆರ್ ಗೇಟ್ you had an inverted output. Now who is sitting inside the flop is there, right? Flip flop. So this is connected to the D and output Q is connected to the inverter. So like this it is going to work. So that's why it is registered output. So only that is the change. So this figure also you should show. So you should check whether he is asking for 16R8 or L8 in the exams. This what we'll do is I'll take this generic array logics I'll take in the next class. So before when you come for the next class you have to draw these two circuits. Programmable logic arrays, first one is PLDs. First example is PAL. So 16L8 and 16R8 figures you have to draw. So in the next class, and parallelly you draw this GAL figure also. Yeah, right?